G'day. A bit under the weather at the moment, a bit of a stuffed up head, but we'll work through that. Today I thought I'd show you a cylindrical square. These things are basically a piece of typically ground steel, very parallel or very cylindrical, and with the ends perpendicular to the axis of the cylinder. And you use those for checking regular squares like that one. And it's a simple bit of kit to make, but at the same time, it's if you're concerned that your squares might be out or you want something to check them to, show you how to make it, show you how to check that it's good. And when you put this on a surface plate, this gives you a right angle, which you can then check squares and things against. Features are as follows. As I said, that's cylindrical. The actual diameter doesn't matter too much. The top and the bottom are both got a recess in them, so you've only got, when it's standing on the surface plate, it's only sitting on that rim, and that's one of the tricks of these things. There's a center in there, and there's also a screwed hole there which is used to put a thread in that you can then drive this, so you make these between centers. This is a piece of EN25, 50 millimeters in diameter and around about 125 long. It's not important, provided it's long enough that your square can go up against it. Now, this is in a, what would you call it, a hot rolled condition perhaps. And what I'm going to do when I put the counter bores in the end there and the counter sinks, I want to hold that in a steady, and that's just so that for you guys where you've got a small lathe, just to show you, provided you've got a fixed D that can take 2 inches, 50 millimeters, you're okay. To do that, I'm going to have to clean up the outside here a little bit so I can get that steady on there. So what I'm going to do is I'm going to put that into a 4-jaw. I could use a 3-jaw, I guess, but I'm going to put that into a 4-jaw. The other end I'm going to need to center. So this little bit is, how do you mark a center on there if you can't put in your lathe? 2 ways you can do it. First way, if you've got a, what would you call that? I don't know what you'd call that. Okay, if you've got one of these things, what you can do is you can put that across the edge of the round stock, scribe, turn it through 60 degrees or so, and do that. Okay, you've got some scribed lines there which should meet in the center. Now if this was a bit more unevenly shaped, there might be a slight difference in those lines, but what you do is you then by eye pick the middle there, put a center punch in, go to the drill press, using a center drill, just drill that lightly so you've got somewhere to put a center in. The other way of doing that, if you haven't got one of them, is like this. If you've got a set of odd leg calipers like that, set that for half the distance. And once again, it doesn't have to be exact, okay? But what you can then do is come along and scribe a whole bunch of lines across like that. And once again, if you can see that, they should meet round about the middle there. So once again, center pop that, and then drill, and you've got a center. Now these are only going to be temporary, but I do need them so I don't have that too much stick out. I've put my centers in both ends, and that was just a matter of holding that in the drill press while drilling down. Nothing terribly complex about that. All I want to do now is basically put, I don't know, 20-25 millimeters worth of cleanup cut on there so that I can run a steady on there without it jumping around too much. So I'm going to do that this end, and then I'm going to flip it over and do that this end. And that's simply so I can then put my steady on and clean up the end, or more importantly, put that recess in there and redo the center. I could have done this between centers and have a dog on here rather than using the 4-jaw. So if you haven't got a 4-jaw that's big enough, then you could do it that way. I have my steady set up. couple of ways of doing this, I guess. If this was bright bar all the way back to the chuck, what you can do is you can bring your steady, centering the material in the chuck, bring the steady right back to the chuck jaws, adjust it in that way, and then move it out. And that should give you something that is pretty close to the axis of the chuck. Here, because I've got a steady and I've used that to do the clean up here, put the steady on, put the center in, and then adjust it up. I only do it sort of basically finger tight, so it's only just touching, and I use a bit of oil there to lubricate. I'm going to run at a slightly slower speed. All I want to do here is clean up this end face and then put a recess in there for, well, just a recess, but then also recut that center. I started out by drilling out the existing centre mark with just in this case a 13mm drill. I then put one of my flat-ended drills in there just to flatten that hole out, and then I used the boring bar just to feed in, because the hole's only very shallow. It's, what's that, 3mm, eighth of an inch. This boring bar could get in there. Normally it needs a 16 hole, but I was able to get in with the 13, and I've just gone and fed up to a stop all the way through. What I'm then going to do is position the tip so it's basically in the hole and feed across, and I'm going to take out probably about 10 thou, 0.25 of a millimetre that way, just to square that up. Once I've got that all squared up, I can then come in with a centre and re-drill that centre. There's a little bit of a dimple there, and it'll probably grab the centre drill just a little bit, but it should self-centre, and that's then going to be my working centre on this end. I've now counterbored both ends, replaced the centre with one that's basically concentric with the running of the outside here in the steady. Now I'll take that out. I'll put a couple of holes in there for the stud, which is being used as the dog, and then I'll put that between centres and clean up the outside. One thing I should have done in hindsight is extend these clean-up areas just a little bit more so I could run the dial indicator on them. I found I had to re-centre this because the centre here wasn't in quite the same, quite on the axis, so therefore this diameter was out slightly to this, only by I think it was something like 10 thou, but enough to make it wobble visibly, so I had to go back and re-centre that based on that machine surface. So I have another dodgy looking setup here, and it's probably dodgy in reality as well. I've got a bolt in the tapped hole on the other end of this, and I've discovered that it won't actually fit on my dog. It's probably because the dog is too big. Now there are two ways I could get around this. This is one of them. I've put a bar across here, and that's bolted on and that's wired on, so it shouldn't come loose, but at the same time I'm not going to be standing in front of this, so if it does come loose it's not going to hit me. And I'm basically using that as an extension, and so the head of the screw is working against the bar. Another option is using a taper like this. What most people don't realise is that a Morse taper isn't tapered from there right the way up to there. It stops probably around about there somewhere, and you can work that out with a ruler, just putting that on there and working out where it starts diverging, or the other way around. So what I could do is dial that up in a 4-jaw, hanging onto that bit, and then use the jaw of the forejaw to drive the bolt. I got up to about here, and then the twitch of wire I had gave way, and so I've had to go to plan B. So I've got my centre sitting in the chuck, and I've dialed that in so that that's absolute centre, and I've got a grub screw in here which is bearing on the side of one of these jaws. I'm not quite sure which setup I like best or dislike least, but it is what it is. Another possibility, I guess, is to make up a special centering plate of some sort for this. To get this properly cylindrical, the centre line of the centre here has to be precisely lined up with the spindle of the lathe. Now, two ways of doing this. The way I was originally taught was you measure that, you take away half the difference and you move your tailstock over. However, a way that I've developed is that if you put a cut on, that cut is going to be parallel with the axis, assuming your bed's not wonky, on this side. But on this side, it will be conical. And so I set this dial indicator on 0 up here, and have run it along the bed, and it's reading about 5 thou big, which means that I need to move the centre over around about 2.5 thou, and then the next cut I take, that should be good. Now, in theory, you could also do this if you ran an indicator along this side as well as along that side, provided they both deflected the same amount when they got down here. You could say your tailstock is properly aligned. Now, when you adjust this thing, there's normally a couple of bolts on the side, and they're hidden down here so you can't see them. But it's a good idea to actually take the clamp off the bed, as in unclamp it, and then clamp it back up again, just to check that that adjustment is right. Because what will happen is if you unclamp that tailstock, sometimes that's contributing a little bit of friction that stops the adjustment working properly. And so as soon as something changes here, that will muck up your cylindricity. I've got my tailstock across, so I'm getting a parallel cylinder here. I still need to give that a bit of a polish. The finish is better than it was for a couple of reasons, but I still need to do something about that. One of the reasons is carbide. Carbide runs best at a particular speed, or a range of speeds, and it's generally quite fast, whereas high-speed steel can go a little bit slower. And when you're turning something like this, which is, think of it as a large weight on two flimsy supports, it tends to want to chatter and vibrate. And so I've got this down at 80 RPM. It's taking forever to do a pass, but that's simply because if I go any faster, I start getting lots of chatter and vibration on. Gone down to high-speed steel because I've got a slower surface speed. The other thing I'm also doing is I'm using what I know as a shear tool, and I don't know whether you can see it, but you can see that the tool dives away that way. And the idea being that when you're using a standard tipped tool, the material comes down and sort of curls a chip there. Whereas this is a shear tool, and the material comes away and then sort of glances off to one side, and so that's giving me a slightly better finish. They used to be very common on shapers, I'm told, for getting nice finishes out of shapers. Anyway, I'm going to give this a bit of a polish, but before I do that, one of the reasons I'm using a stud in the end to drive is I'm going to come in with a tool, probably that one, and I'm just going to square up that edge so that because my cross slide is at 90 degrees to the spindle, if I've got that parallel, I can then come along in here and dive in, and that will make sure that that face is perpendicular to. Lathe specs say that that can be a little bit concave, so either way it doesn't matter because it's going to be sitting on that lip, and that's how we're going to guarantee the squareness. How do you test whether this thing is any good? I'm using my ground one here, the one I was making up. There's still a scratch or two which I need to work out. When you're polishing on a lathe, it's easy enough to take a thou off, and so one of the things you've got to watch for is that you don't overdo it in some areas. And what I'll tend to do is, as I did for the shaft, the air spindle shaft, was I'll divide that up into segments, measure each one, see what the difference is, and then work on each one sort of individually to knock off the high spots. In this case, because there's that scratch there, I need to, bring that out. And the other thing is too, when you're running emery across, the natural tendency is to do that. Unfortunately, what that means is the ends here get sort of a double dose, and so you really need to sort of do that, right? And so you're not dwelling on a particular spot, so that those ends are a little bit undersized here too for this, so I need to bring that down. When I say a little bit, I'm probably talking about 5/10 or something like that. Yeah, the way you check these things is there's two steps to the process. One is use your micrometer, and you just measure it top and bottom. And if you get the same reading, you can assume that that's, it's cylindrical. It's not conical, whichever way that may go. And I've done that, and that came out to 2010 inches, so that's all fine. Then you need one of these, and this has got a curved piece on the front here. And what you're doing is you're going to line that up, and I'll see if I can get that there. You're going to line that up and just sort of move that round. Right, until you get to what would you call it, a minimum, maximum, whatever, maximum deflection, I guess. Note where that is, and then turn it round and do the same thing. And what should happen, right, so about the same spot there. But what that means is that the point of contact here is the same distance from that, and so you can say, right, that's cylindrical, and between that point and that point, and that point on the back and that point is the same vertical displacement, and so therefore it's square to the surface and it's cylindrical. And so that gives you that's the check for a cylindrical square. And then you can just come along with your squares, and if you need to, put a bit of light in there just to see what they are doing. That might be a little bit better there. So you can see on this one that the bottom is doing pretty well, but from about there up, there's a fraction more daylight. So if I was of a mind to rework squares, I'd probably, try and take a little bit off there until that lined up. Anyway, that's a cylindrical square, and one way to make them, but also how to check them. And there you go, another piece of cheap measuring equipment. Thanks for watching. See you for the next one.